Right, good evening, everyone. Um, our trainer is logging in because small issue. I will, yeah, so we'll start. So I welcome you for the second session in our series of placement training from VTU CPC. And as part of a series of engagements that the CPC team will start doing. This is one such engagement, and uh, some of us are preparing for the Infosys drive, which is scheduled at different times for different regions, and for some it's fixed, some it's going to get fixed, and this is in some sense a lead up to that. And But it also in general will help us as all of us through the CPC platform, Xcelerator platform, are going to get a bunch of new opportunities over the next couple of weeks and months, and you'll have a lot of other trainings and engagements like this. So I again welcome all of you to that. I want to tell you something very important. That is the Xcelerator platform that you all logged in and have just signed up and probably started filling your profiles. And that's how you also probably got access to this training session. It's very critical that you fill in your profiles. Uh, this will help companies on the platform find you. So companies are steadily flowing in and posting their requirements, and it's very, very critical that you fill in your profile. The profile does not have many sections to it. It's a very simple profile, but then we expect you to update all your academic details, all your the certifications you have done, the projects you have done, the internships you have done. And this is the more you fill, the higher the chances of a company being able to find you. So it's very critical, and we encourage each one of you to fill in your profiles in the Xcelerator platform so that companies that are coming to hire on behalf of VTU Central Placement Cell will be able to find you, and you can also see more opportunities. Sure. One second. Okay, so we will start our training for today. We welcome Mr. Kushal. Kushal did take a session for us yesterday too, and he will be continuing with that today. And Kushal, can
Yeah,
you
I can
acknowledge if you
hear
are able
you.
to
Yes. Am I audible?
co-host the session?
Yes, am I audible, sir? All right.
Okay.
Yeah, very good evening, everyone. I hope everyone are doing great. So we'll get started.
A quick brief intro about Kushal. Kushal happens to be a certified technology manager in the space of digital development. He's also a certified front-end web developer, a certified Spartacus developer. He's also worked on React Native. He's a Python associate and a Python programmer. Over to you, sir.
All right, so thank you so much. So all right, guys, we'll get started. So let me quickly recap what we have discussed yesterday. So I'll start sharing my screen. Can someone confirm me if my screen is visible? All right, guys, thanks for the confirmation. Good. So yesterday, like we have gone through what is a pattern relevant to Infosys. So like as we have discussed, so there are 5 questions to be answered. So we get 10 minutes of time. So 5 questions to be answered. So we get 10 minutes of time. So in these 10 minutes, so like you can just spend like 1 to 2 minutes with respect to the question and you can go forward. So as per yesterday's class, so we have seen what are operators, decision making statements, if, else if, switch case, control structures, for, while, do while, followed by somewhere we have gone through break, even. Then so like as yeah, this is the pattern what we have discussed yesterday. C++ data structures questions would be asked. So we have gone through all the basics in our yesterday's session. So starting from our operators, so like we have gone through each and every bit of the operator. One sec, guys. Let me disable the annotation. Cool. Let me reshare. Cool. So we have gone through all the operators, arithmetic, logical, bitwise, followed by we have seen what are true cases, what are false cases. So we have seen certain examples, how if works, how if else works, how else if works. All right. So then we came to the picture of else if. Then we have seen something like switch case. We have seen the same case, why we are going for the block of else. So what is conditional operator about? And loops, we have gone through for loop followed by while loop. So we have seen some difference with respect to for versus while. So we discuss something like wherever we need some condition, so we need the while loop in picture. So wherever we don't need any condition, so we go for loop. So then followed by some examples, some pseudocodes has been discussed. All right. And also we have discussed something relevant to functions. So this is what we have discussed in our yesterday's session. And for these functions, so we went for the concept of recursion. Okay, like where we got the answer when you call function of 4, the answer is 0, 1, 2, 4. So this is what we have seen yesterday. So before to get started with today's session, so may I want to know like how many of you are having any doubts in yesterday's question? Maybe like have you practiced at some moment? Any queries? Anyone? If you have any queries, you are free to put those in the chat. Okay, I see one query. Okay, single slash is used for float results and double slash for integer results. Yeah, so basically like 5 by 2 is 2 only. So let me just add 2 points. 5 by 2 would be 2. So like when I'm working on C, C++, Java, we get the answer to be 2. When I work on Python, 5 double slash 2 you get 2 and 5 slash 2 you would get 2.5. Okay. Is my voice fine to everyone? All right, great guys, good. So 5 by 2, basically I would say in C, C++, maybe in Java, you get the answer to be 2. So where you work on integers, but 5 double slash 2 in Python only, that would be working as a floor value. Okay, but this would result single slash as a float. So this would be float. So in Python, so this would be as a value flow. Okay, my voice seems to be breaking. Just give me a moment, guys. Maybe let me reconnect to my audio. All right, guys. Now is it fine?
Your voice is fine. No
All right.
issues.
Thanks for the confirmation. Maybe just check with your internet connection, guys. All right. So let's go ahead.
So just one request.
Sure.
Not all students uh, who were part of the session yesterday are here. Having said that, there are also students who couldn't be part of yesterday's session but are new to the today's
Okay.
session. So
Okay.
if you can give a small gist about what was covered yesterday and move
Sure.
forward,
Sure.
maybe they can
Sure. 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 Yeah, we'll go ahead the same. Okay, I've started sharing my screen, guys. Okay, so let me quickly walk through for the first 10 minutes. So what we have discussed in our yesterday's session. So like I have covered what are operators about. So in operators, like we have seen how modulus works, how division works, how plus plus minus minus works, and of course the same standard things like plus, minus, multiplication. So here slash stands for quotient, modulus goes for remainder. So and we are also seeing something like, so when you're trying to divide any number with 5, so you get the reminders from 0 to 4. Similarly, if you try to divide by 2, you get the reminders from 0 to 1. Similarly, with 10, you get the reminders of 0 to 9. So this is something with respect to the modulus operator. Maybe if I try to divide with 20, so what we can get the reminders, guys? Some quick responses in the chat. Yes. So we will get the reminders from 0 to 19. All right, good. So that's something about arithmetic operators. And next we have seen something like logical. So logical meaning if any of the condition is false in case of logical and. If any of the condition is false in case of logical and, so you get the answer to be false. Similarly, here you see false and true, the answer is still false. True and false, the answer is false. So true and true, the answer would be true. So meaning if each and every condition is true, we get the answer to be true. So when we go for logical or, so let's say here, if each and every condition is false, the output would be false. If any of the condition is true, you get the output to be true. So if you observe the last three cases, the answer is true. So because we have one true over here and here, either of the statement is true, the answer is true. When we go for logical not, if it is false, you get the answer to be true. If it is true, you get the value to be false. Simple. Let me just take some example here. So we assume that there are some conditions starting from 1 to n. If let's say the condition 1 is failed when we are working on logical and. So if the first condition itself is failed, there is no need to look for all the next conditions. Simply we can ignore them. So even though they are present, we are not looking into them. So still the answer would be false. So let's say the same case if you work for logical or, if the first condition is true, there is no need to again go and look to all the other conditions. So here comes a picture of logical or. So when I would say logical or, logical and, there is something about true and false values also. So that I have covered over here. So false values are nothing but something like false, 0, 0.00, null, none, or 0 plus 0j, some empty things. So if I say empty things, something like empty string, empty list, empty set, so empty tuple, so whatever which is an empty, so we say that is to be a false value. So apart from this, you try to pick anything, all those are considered as true. So maybe if I take true, a number, true, float, true, a random address, true, complex value, true, a string, true, an array of four values, true. Here we took 3 plus 0j, it's also a true. And also here if you observe, so we have something like list, a set, as well as a tuple. Inside those, we have something like 0 because it's not empty. As it's not empty, so we can consider that as a true value. So if you observe here, I took one more example, 1, 2, 3, logical and 4, 5, 6. So 1, 2, 3, if you observe, is 1, 2, 3 a true value? Yes. Okay. 4, 5, 6 a true value? Yes. So both of them were true. So then of course the answer would be true. So that's something about logical AND. So next we came to the picture of bitwise. So bitwise meaning same guys. In bitwise we have something like bitwise AND, bitwise OR, XOR, left shift, right shift, negation. So let me just quickly walk through what is bitwise AND about. So in bitwise AND, it's something same similar to logical AND only. But here you work on the bits. So bits here would be zeros and ones. Okay, I see a query. Yeah, yes. So you'll be getting the recorded sessions. So I'll be sending the same notes. Followed by this, I'll also send the previous year's MCQs, pseudocodes, what we are going to discuss also. So throughout the end of the session, you'll be getting all these guys. No need to worry. Okay, fine. So here, any of the one bit is zero, the output would be zero. Okay. So here you see 0, 1. So the output is 0. So 1, 0, output is 0. So if all the bits are ones, the output would be 1. Same case it works for bitwise OR. In bitwise OR, if you observe, if all the bits are zeros only, the output would be 0 here. If all the bits are zeros only, the output would be 0. If any of the bit is 1, the output would be 1. Right. So next comes XOR. 0 XOR 0. So what do you get the answer? If both the bits are same, you get the answer to be 0. So let's say here 0 XOR 0, here both the bits are same. The answer would be 0. And if you observe the last case, both the bits are same, 1 XOR 1, the answer would be 0. If the bits are different, so 0, 1, 1, 0 bits are different, the answer would be 1, 1. Right? So if I just take some quick example, can someone tell me what is the value of 17, or maybe quickly let's go for 6 XOR 6. What do you get the value of 6 XOR 6? Yes, yes, the answer would be 0, right guys? So because in 6 if you consider, you get the bits to be 110, and if you also consider the other 6 also, you get the bits to be 110 only, right? If both the bits you are getting the answer to be same, of course the output would be 0, right? That's how that would work. So next comes the picture of left shift and right shift. So like what's left shift and what's right shift? So left shift is nothing but if you have the, okay, you already had the Infosys drive at your college. So can you get other chance to write the test? I guess you might not be able to write, but if you write the exam once, so again it might need somewhere 3 months to 6 months to write the exam again. So you can just check with your college training placement officer. Maybe they might get back to you on the same. All right. Maybe as per the Infosys rules, like they would be going for minimum 3 months or maybe next 6 months of duration. So that again you re-attempt the exam. Okay. So let's get back to the concept. So left shift followed by right shift. So left shift meaning guys, you are supposed to multiply with the base. So right shift meaning you are supposed to divide with the base. So let's take the example here, 5 left shift 3. So 5 left shift 3 meaning what is that exactly? You're trying to do 5 3 times left shift. So means into 2 into 2 into 2. So like what's the purpose you are multiplying by 2? As we are discussing something about bitwise, you need to multiply by 2. Okay. So let's say here 101 is your value. Each and every time when you do left shift, you get the answer to be zeros at last. So now you see the value 5 to 10, 10 to 20, 20 to 40. Similarly, when I say right shift, 4 times you divide by 2 4 times. So nothing but left shift means adding 0 in that respect to base. So here 101 is in the base of binary. There you add the zeros. Similarly, 40. So right shift 4 means, so what are you getting the value of 40? 101 000. In that respect to base, what you need to do? Divide. Divide means last 4 bits will be removed. So means you get the answer to be 10, which is 2. So this is how it works of left shift and right shift. Of course, binary you are working means multiplied by 2 and divide by 2 will be doing. But if you work on any other base, let's say you are working on decimal base. If I ask you to right shift, what exactly happens? So 1, 2, 3, 4, 5. Right shift means you divide by 10. So meaning the last digit is removed. That's how you write the code for finding number of digits of a number. So this is what you write. So while number greater than 0, count is incremented by 1. So number you divide by 10. Right? So this is how it basically works. And next, like we came across something like conditional operator. So when it comes to conditional, maybe before that we have also seen assignment operator. So like plus minus, minus equals, bitwise and equals, left shift equals. So if you see here, number to be 5, number plus equals 20. So meaning that number would be 5, number plus 20 we are trying to do. Okay. Okay, left shift. You want me to explain once again? Hold on. Right. So left shift meaning guys 5 left shift 3. So what you are supposed to exactly do is you multiply by 2 with the value 5. So if I take the value, let's say 5, left shift 3. So as left shift is a bitwise operator, we need to multiply by 2. So 5 into 2, again multiplied by 2, again multiplied by 2. So 5 2 is 10, 10 2 is 20, 20 2 is 40. This is what you get. Maybe if I take the value 40, left shift 2. So you get what? 40 multiplied by 2, again multiplied by 2. So 82's you get 160. So this is how left shift works. So when it comes to shorthand assignment operator, okay, right shift also again. Cool guys. I'll do that. Yeah. So before just going to all the things even, so like maybe I'll just show you something. So like I have a YouTube playlist. So like where I have detailedly explained out. So what are all the operators about? Okay. So like if you go to the name Deva Kushal over here, so you should be able to find some playlist. Okay, where you should be able to see somewhere like problem solving crash course with Python. But even though it's on Python, operators, concepts, if else, everything would be still the basics. Just a second, guys. So let me just maximize that. So over here, you will be able to find all the basics things, guys. So like what are arithmetic operators, logical operators, bitwise operators, relational operators. All the operators I have covered it in detail with all the examples and all the edge scenarios even. And how do you read the input, how you are supposed to print. So even if, else, else if, why we need to go if, why we need to go to else, what is the purpose of else if, and what is the for loop, what is for loop, how you work on, what is while, for was while, all the basic minor things you should be able to go on with this starting 23 videos just to understand. Now, if you want to go on work around something like problem solving, you can just go through the below questions even. All right. But even though I'll just try to cover as part of this. So let's see here. Right shift meaning guys, 40 right shift 4. Okay, so 40 right shift 4 meaning what is that? So we are supposed to divide. Okay, let me share that in the chat. Okay, all right. Yeah, I'll put it in the chat, guys. You can just go through them. Fine. All right. So 40 right shift 4. So meaning what exactly happens, guys? You are trying to divide by 2, correct? So 40 by 2, it's 20. 20 by 2, it's 10. So 10 by 2, it's 5. 5 by 2, it would be 2. Okay. Yes. So this is what exactly happens. Maybe if I take 100 right shift 3. Can someone tell me what is the answer of 100 right shift 3? What's 100 right shift 3? Yeah, I see answers. Yeah, of course, we get the answer to be on integer only. So meaning 100 by 2 first, the answer would be 50. 50 by 2, so you get the answer to be 25. 25 by 2, you get the answer to be 12. So this is how it works. Yes, 12 is the correct answer, guys. Yes, good guys, awesome. Okay, so maybe something like bitwise and equal. So here we are using the combination of bitwise operator and equal to. So what is that meaning is, if let's say number is 5, number bitwise and equal to 2 means what you are trying to do? You are trying to do number bitwise and 2. Sorry, bitwise and 2. So this is what you are exactly trying to do, guys. Number and equal to 2 means number equals to number bitwise and 2. This is what exactly happens. Cool. So of course, like 5 bitwise and 2 would be evaluated. 5 would be 101, 2 is 010. So what do you get the bitwise and between 5 and 2? You know the answer. Yes, guys, you know the answer. What is that? Yes, it's 0. Absolutely right. The answer is 0. So because any of the bit is 0, right? So of course the answer would be 0. Right? So this is how it works. Okay. So next, of course, you know the operation, something like relational. So relational meaning you compare double equal, not equal, greater than, less than, greater than or equal to, less than or equal to. All those would be part of our relational operators. So, and of course, we have something like membership, identity operators in Python. So those were not relevant to all the programming languages. So we can simply ignore them as part of this discussion. And apart from this, we have also seen something like if, else, else if, followed by switch case. So I'll just quickly go through what is if, else. I'll take a new paint file. All right. So let's say here, guys. So if meaning the condition is true, of course, we get into that respective block and you work on. And there is a scope of going with if condition 1, some block of statements, if condition 2, some block of statements. But in order to check the same condition again and again, what we'll try to do, we'll try to skip the part and we'll go for else. So instead of if, once again, we'll go for else. Okay, how to access the recorded sessions? One sec, guys, maybe let me just check with the team and I'll let you know. So wherever you are trying to access the link, there only you should be able to access the recorded sessions. Or maybe just give me 10 minutes of time. So meanwhile, I'll just check with them and I'll put it in the chat. Okay. Right. So instead, if, so we go for else. So meaning, guys, instead of checking the same condition again in a reverse way, we go for else part. So let's say if you want to check some number is even or odd. So what you are supposed to do? If you want to check some number is even or odd, what you are supposed to do? You can put your answers in the chat. How would you check some number is even or odd? Okay, number modulus 2. Okay, you compare with 0. Right, exactly. So you do number modulus 2 and you compare with 0. So if number modulus 2 double equals 0. So why we are trying to do with 2? Because, so yes, why we are trying to do with 2? Because you need to check it's a multiple of 2 or not. So what are multiples of 2? 2, 4, 6, 8, so on. All these are multiples of 2, right? Yes. So when I say modulus 2, here also you can go back to our things what we have discussed, guys. Maybe let's say here some value 5. So what is the value of 5? 101. So what is 5 modulus 2? This is the one, right? The last bit you get it. Yes. So 5 modulus 2 would be the value 1. So in that respective base, you get the answer to be 1. Yes, if it is 0, you can say that it's a multiple of 2, even or odd, simple. Okay, you just simply write over here saying that it's an even number. If that's not the case, you simply go for else. But let's say if I would write if number mod 2 not equal 0, so can we just simply write again print odd? Yeah, of course we can do in this way. But what exactly is happening? You have already checked the condition over here. And again, what is the purpose to check the same condition in a just quite opposite way? So instead wasting the time, we go for else. Yes, time consistency comes into picture. Good. So instead the same, we go to what? Else. Yes. So I'll just remove this if part. So there is no scope of to add. So we'll remove this and we'll simply go for else. Yeah, that is how this works. Similarly, else if also, guys, if there are more conditions, let's say if there are 100 conditions, so condition 1, 2, 3, 4, so on. Next, I would say condition 20, so on until 100. Maybe I want to stop at the condition 20. Okay, all the first 19 conditions got failed. So you want to stop at this point. So what you are supposed to do, you need to go for else if. But if you go for if, what exactly happens? Even though this condition 20 is satisfied, you go until the condition 100 just to check. Just you are wasting the time. So that's the picture of else if. Okay. So we have just taken the same example in our yesterday's session. So like here our requirement is in our room 5 there is a bag. So you want to capture that. Okay. So you start from room 1, you go till 4. So once you go to the room 5, you take the bag and you are supposed to stop. But even though after you find what is the purpose to again go and check. So 10, 11, 12 until 50, so on until 100 doesn't make any sense, correct? So even though you find there is no purpose to check. So if you are checking, you are going for multiple ifs. So once you come out, once you find, let's say the second condition got satisfied, you simply come out. There is no need to go and check the third and fourth condition even. So that's the difference of if and else if. So next comes a picture of switch case. In switch case, maybe if I pass the value 1, what happens? 1 is being passed. You go to case 1. You go and evaluate this respect to statement. But what if there is no break? If there is no break, it tries to execute all the other cases until you find the break. So of course, the last condition default, there is no need to have the break because after that you are simply coming out of switch case. Correct? So this is what exactly we have done. So if you just skip break, what exactly happens? So for first case would execute, case 2 would execute, so on until the last case. So maybe if I want to write the code for even or I mean like oval or not, we can go for switch case in this way, guys. Just observe the switch case over here. So case, we first let's take some character. Okay, character to be I. Then you go for switch. You have ch passed. Then you have case, case A. Okay. Then you have case E. Okay. Then you have case I. Then you have case O. Similarly, you have case U. Okay. So, but after case U, in the case U only, what do? I will write the print. I don't want to write the print for each and every statement. So what do I print here? Print simply it's a novel. And of course that I would use break. So we will just write break. Next comes a picture of default. If either of these conditions were failed, then I can simply say that it's not an vowel. Just simply write not vowel, or you can say it's a consonant. You just observe here. So the condition over here is I. So case here failed, E failed. It goes to simply case I, but there is no statement. It's empty, guys. It's completely empty in case I. So then it goes to case O. It's completely empty. Again, case U, it goes and prints what? It prints vowel. So we get the answer to be over here as vowel. Correct? So we got the answer as vowel. So either of this case is satisfying, you print the vowel and you break. So what if this break is not there? You would print vowel, you'll also print not vowel even. But that's not our case. So we don't want to remove that, right? So this is how switch case works. So even though if you want to keep it empty, it's completely fine, guys. There is no problem in that. Okay, if you want to completely keep all these respective things to empty, this is fine, not an issue. Make sense? Switch case. All right. Good. So next we have the picture of loops, for as well as while. So after that, I'll just quickly get started with the concept of pointers, arrays, and strings. Okay. So let's say over here. So let me take the example of loops. So what is a for loop syntax? For loop syntax would be, so we initialize. So we initialize, we write the condition, and then what do we have? So we have something to update. So initialization, so followed by condition, followed by updation, right? So after these, then comes a picture of body of the loop. This is what exactly we have. So like basically the block of statements. When it comes to while, what exactly happens in while? So of course you have the initialization, then while condition, then you have some block of statements, and then followed by updation. Yeah. So either you increment or either you decrement, guys. That would be fine, right? So either you increment or decrement. So it doesn't matter that you all the time you increment or decrement, but when you go for the code to find number of digits, what you're trying to do there, you're trying to divide by 10, correct? So what you're trying to do, you're trying to divide by 10. So like you initialize some number to 1, 2, 3, 4, 5. So while your number greater than 0, what do you do? Divide the number by 10. So this loop runs for 5 times. This loop runs for 5 times, right? Makes sense? So, so there is some beauty, guys, actually. What the thing is, so whatever you try to do the for loop in C, C++, Java, so what all things you can do on for loop, the same we can do on while loop even. But as I have discussed yesterday, the same won't work in Python. Okay, so just to add on to the students who got missed yesterday, so 2 more points. So let's be pretty quick. All right, it got opened. Fine. So let's say here, I'm just taking some value called size to 20 per I in range of size. Then I would print something like I into some space. So what are the answers we expect over here, guys? So what is the result we expect over here? Yes. So of course the answer would be 0 to 19, right? So we get that in a single line. Okay. So just one more modification over here. I would increment the value of I by 5. So now what would be the answer's expectation over here? Yes. Yes. Okay, I see some different. Okay. Yes, guys, the answer would be still the same 0 to 19 only. That's the thing what we need to understand range function about. So that's the reason all the time I would say. So when you are pretty much confident about the basics, how the in, how the out would work, so then we can see. So let's say here, why it's not working is the value of I is not incremented. It is incremented, guys. It is incremented, but just try to observe. So using the same loop, I'll add one more print saying the value of I. So yeah, of course, that would print in different lines. You see here, 0, 5. Value of I is incremented. But for the next time, when the loop starts, what exactly happened? I value is 1. Okay, so I value is 1, meaning it is trying to pick the fresh value from the range again. So why the thing is happening in this way? Because here for loop is iterating on something called range, and that range is a built-in function in Python. So once you define the function would be fixed. No matter you increment the value of I, even no matter you try to modify the value of size, it doesn't matter, guys. Now if I just take the same code, instead of incrementing the value of I, so let me write size equal to 3. So meaning what? It should only run for 3 times, but you see still it is running for 20 times. That's how the value of size is first defined as 20. Now if you see the size value, it's 3, it got modified. After the first loop only, size is modified. But whenever the loop runs next time, this I value would be picked from range. So if you understand this difference, if you code anything in the future, so maybe not for pseudocodes, but for problem solving, so you'll be able to understand why it's not working. Maybe at some point you want to decrement the value of I. Let's say maybe I want to decrement the value of I due to some reason. Okay, due to some reason you want to decrement, but it won't work. So that's due to why, guys? It's due to this range function. So if I give to the range as 20, so no matter you want to do anything or you want to increase, decrease, multiply, all those things won't work. So let's say maybe I'm just taking size value as 20. So for I in range of size, so just print the value of I and equal to space. Right, 0 to 19 you got. So after that, I'll try to still increment. Do we see anything change over here, guys? Maybe if I increment by 100, do you see any change over here? No. Why no? Because the range is a built-in function. You see whatever is in this purple color, it is said to be built-in function. Whatever which is in this orange color, it is said to be a keyword. Okay, there is no change. Still the answer would be 0 to 19 only. Okay, so I is modified, but for the next time when the loop starts, I value will be reinitialized. So that's the reason. So no, in Java, of course, you don't have this syntax, right? You again still go for the same syntax what we go over here. This is the one, right? In Java you follow. I mean, this of course you work in C, C++, Java, it's still the same. Okay, please explain this code once. Which code you are expecting? This one? Okay, so like size to 20, right? So size 20 I have took. So this loop, what we are trying to say, we are trying to say that to run for 20 times. So even though you increment the value of I to 100, it will not modify. Why? Because here range is a function where it only accepts for the first time. Okay, maybe if I also even still increment or decrement the value of size by 1. Let's say size is incremented 20 times, loop got run. What do you print? 0 to 19 means 20 times size is incremented. Then what would be the updated size? Size would be 40. But is this loop running in that way? No. If you write the same piece of code in C or in Java or in Python, I mean, or in C++, it would go infinite times. Why? Because each and every time your size is increased, there is all the time 20 difference. So then what exactly happens? You would go to infinite. Understood? I hope that makes sense. All right. Cool. So that's it. Something about the basic introduction, guys. And even you'll also be able to find the same over here. So maybe if you see, find something like for was while over here, which one to choose. So I've explained like how does this for loop works and where does while loop works, where does for loop fails. You can just walk through like when you get some free time. Okay, cool. Let's come back to the same. All right. So this is something what we have discussed yesterday. And now let me also go through some pseudocodes. So before getting through pseudocodes, I'll quickly walk through arrays, pointers, and strings. Then we can simply spend some more time on pseudocodes only. All right, guys. So let me just take something called pointer. So of course, a pointer is nothing but it's a variable. What does that do? It points to other address. Of course, it points to other variable. So of course, like you try to store an address, right? So pointer is a variable which is storing I see some query. All right, fine guys. So what is a pointer? So pointer is nothing but it points to another variable where it tries to store the address. And let me just quickly take something like number to 5. So maybe if I say this is an integer number, okay. So like we have something like int star pointer. So nothing but what I'm saying here, PTR is nothing but an integer pointer. Maybe you can have something like float star PTR2, PTR1, similarly char star PTR3. So all these things would be present. Okay, now let's say here. So what do you do? So I have something like a number. So what do you have? You have something like a number. So maybe let me just say, all right. So what is the value of number, guys? We see the value of number is 5. So maybe this number would be presented some random address, let's say 100 or 1001. Okay. So what's the variable name you have? The variable name for this is num, correct? So now here, if I would say there is a pointer called PTR, PTR1. So PTR1 is nothing but it's an integer pointer. So what I would do, I would create one more, maybe something similar to it. Okay, but let's say some different random address. So I'll go for address to be 2001, any random address, guys. That's fine. So this is said to be something like PTR1. Okay, PTR1, nothing you have at the beginning. So let me remove this value 5 from that. Cool. So now what you're trying to do, let's try to do something. So now what I'll do is PTR1 holds the value of number. So PTR1 would be address of number. So PTR1 would be address of number. So meaning what? What is the address of number? 1001. So 1001 is stored at PTR1. Okay, now what exactly happens in memory, guys? PTR is pointing to this respect to memory location. PTR is pointing to this respect to memory location. Here comes very important point with respect to pointer. As PTR1 is an integer pointer. So can someone tell me what is the value of PTR1? Yeah, let me just walk through once again. No problem. So PTR1 value would be 1001. So let's say here, what do I have? There is a number called 5. The address of that number is 1001. So you have 3 pointers, int star, float star, char star. PTR1 is an integer pointer. PTR2 is a float pointer. PTR3 is a character pointer. Okay, like what does that make difference? Let's try to understand now. So what I have break down that over here. If you see here, PTR1 is holding what? It's holding the value of my number. So what's the number? 5. So what's the address of the number? 1001. So that's nothing but you hold it in PTR1. Cool. PTR1 is said to be integer pointer. So what is the difference if it is an integer or float or character pointer? There is a huge difference, guys. Let's say here PTR1 plus 1. What do you get the value? What is the value of PTR1 plus 1? What is the value of PTR1 plus 1? Any guesses? 1002. Okay, I see one next address. Right. Yes, guys. So here we are not sure what is our next thing. PTR is a pointer, right? So when you increment the pointer by 1, it goes to next address. It's not a simple addition operation. So when I would say PTR plus 1, it simply goes to where? Next address. So why next address? Meaning, let's say in our case, okay, in our case, maybe integer is holding 4 bytes. Let's say integer is holding 4 bytes. If integer is holding 4 bytes, so what can I say? If I increment something plus 1, then that would be 1001 plus 1, meaning it would be 1005. So again, 1001 plus 2, meaning 1005 plus 1, meaning 1009. Each and every time 4 bytes would be increased. So if I would say here PTR2, so PTR2 is a float pointer. So let's say PTR2 value is 1000. So what is the value of PTR2 plus 1? What is the value of PTR2 plus 2? Let's assume that float is of also 4 bytes. What do you get? This to be 1004 and this to be 1008. Simple. So this is how it works, guys. Okay, float is also assumed to be 4 bytes. If float is also assumed to be 4 bytes. This is how it works. Cool. Okay, now here comes last question to you. PTR3, I'm saying it is a character pointer. It's a character pointer. So PTR2 value is 5001. So what is the value of PTR2 plus 1? What is the value of PTR2 plus 3? So 5002, yes, and 5004. Yes, 5002 would be for the first one and 5004 for the second one. So because character is assumed to be 1 byte. So character is assumed to be 1 byte. So this is how it works. Right. So the same thing we can go with the concept of array now. Okay. So let me just walk through with the array. Let's say this is an array. Okay. In this array, I'll just take the indexes starting from maybe 0 to 4, assuming that there are only 5 elements. Cool. So 20, 30, 40, 50, and let's say 60. So these are all the elements in the array. Now I would go for the name of the array as ARR. So what is an array? Array is nothing but it's a collection of homogeneous elements, right? It's a collection of homogeneous elements, right? Cool. So now here, let me take some random addresses now, guys. So this would be interesting. Okay. So let's take some random addresses. So I would go for maybe fine. Okay, I got a question. So pointer is memory address, how it is stored in another address. And in Python, there is no pointer. No, in Python, we have pointers, but all the pointers are internal pointers. Like what are internal pointers? Meaning like you don't have the access to that. Okay, pointers, like every programming language definitely has pointers. Okay, but you have pointers, you'll not be able to use that explicitly. There are internal pointers. Okay, so but what's the disadvantage of having pointers? Disadvantage of having pointers is nothing but you know the address. If you know the address, what matters, guys? You go to the address, modify whatever you want to modify. Then that's of course like it's like a security threat, right? Okay, you know the address. What, like if you know the address, what would you do? You go to the address and change whatever you want to change. Maybe even though, let's say, okay, before coming to this array, I'll just discuss one point on the same pointer. Let's say you have something like const, guys. Okay, you have something like const var value. I'm just going for 34. So const value. Let's say the value is 34. Okay, maybe of course if I just would say that to be integer. Okay, so this is an integer const value. The value will be 34. All right. So now what I would do is I'll just take a pointer which is of int star ptr, so which tries to hold the address of value, or maybe I'll just quickly say num instead value. Okay, so you have something like num. Cool. Okay, int star ptr would be address of number. Okay, now exactly what happens? Const int number 34, ptr is trying to hold the address of number. So like if I am making something to be const, what if I try to make the value to 50? This is a blunder, right? You are not supposed to do. Why? Because you made it as const. Then why we are supposed to modify it? If you want to modify, don't modify. Just remove the const and you want to modify, then you modify. But as we put it to const, you are not allowed to modify. Okay, this is not possible. Cool. So PTR is doing what? It's trying to holding the address of the number. As you know the address, if you want to modify or if you want to access something in that respect to address, I'll say star PTR. So value at that respect to PTR is what? Something like the value 34. Now, if you want to modify star PTR, maybe I would just assign to star PTR plus 5. Now that 35 would be modified, sorry, 34 would be modified to 39. Even though you put it to constant by using pointers, you are able to modify. That's the reason if you have the access to the address, so we go there, so we want to modify the data or you want to corrupt the data. That's the reason in Java or in Python, you don't have the concept of pointers explicitly, but there are pointers. All those are internal pointers. Okay. Yeah. So that's something about pointers. No, like it's not on C, C++ or Python, guys. Just the basic. Okay. So maybe if I would say like, okay, you see it, the syntax. This is a function syntax, right? This is a while loop syntax, right? They would explain you, okay? So while I less than n, you increase its sum by 2 times I. So pseudocodes are nothing but this. Okay. So let me just take an online C compiler. Okay, let's take anything program is or GDB. It's fine. Now I'll just try to show something like const thing only. Okay, let's just check that part. Const int number to be 34. Okay, so let's take a pointer which is of integer, just trying to hold the address of the number. Now let's try to modify number to 39. But of course it won't work. Let's try to run this and check. So even we know that it won't work, right? But let's give a try. Okay, what did you got? You got something like, okay, this is a warning. Warning can be ignored, guys. That's fine. This is an error. What's the error? Assignment of read-only variable number. Oh, so number can't be assigned because it's a read-only thing. That's the reason you put it to const. Now this is fine. We know that we got the error. Now what I will try to do, star ptr is a value 34. Now by using that, I would try to modify star ptr plus 50. And if you want to print the value printf, like what do you do? Percentage d followed by, what do you say? The value of number. It should be still 34 if it is not being modified. But this is modified. What do you get the value? 84. Let's try to run this and check. So you see the value, guys. We got the answer to be 84. Okay. This is what you can do. So you go to the address, modify whatever you want to modify, corrupt the data. Okay. That's the reason in Java or in Python, we don't have pointers which are explicitly available to work on. Okay. That's something about that. I hope that should make sense. Good. All right. Fine, guys. So let's say now, let's come back to the concept of arrays. Arrays are nothing but what? So what I would say, arrays are nothing but collection of homogeneous. Okay. If you want to store 100 elements and you want to use those 100 elements somewhere in future, then you need some variable like 1, 2, 3, 4, 5, 6, 7, so on until 100. Do you remember all those names? No, right? That's the reason we only have one name called ARR, and you keep all the values, and everything would be one beside the other. So let's say now the address of this would be 100 initially. Okay. The address of next one would be 104, guys. Because it's an integer array, the address of next one would be 104. So next is 108, 112, followed by 116. Good. So this is what exactly happens when you work on integer array. Okay. So now let's say here ARR. So ARR meaning, it is an address. The address of that is 100. So even though if I say address of ARR also, it's still 100, guys. So meaning ARR is said to be a pointer, because what is that holding? It's holding the address. Okay, if you want to access something inside that, what would you do? I would try to go give the index like array of 0. What is array of 0? 20. Array of 3. What is array of 3? Get the value to be 50. Okay, now let's say, guys, star ARR. Star ARR means what? We know ARR means 100. So what is the value at the location of 100? It's 20. Got this point? Star ARR means 20. So value at the location 100. ARR is 100. So value at the location 100, you get the answer to be 20. Okay. So now if I would say ARR 100, ARR plus 2. What is the value of ARR plus 2? Some quick responses in the chat. What is? Yeah, 108 is the answer, guys. So 100 is the thing. So 10, okay, 100 plus 1, you get 104. 104 plus 1, you get 108. Okay. Okay, let me explain once again. I see one query. Okay, so ARR means 100. Okay, ARR is nothing but, we say it as the base location of the array. So ARR meaning same, 100 is also meaning same. So if I say ARR plus 1, what exactly happens? It tries to goes to next location. What's the next location? 104. Then followed by it goes to next location, which is 108. So meaning 100 plus 1 is 104. 104 plus 1 is 108. Okay, that's the reason if I write 100 plus 2, you get the answer to be 108. Okay. So if I would take the same for character array. So let's take some character array here. Okay, character array. So next, maybe I'll just take hello, H, E, L, L followed by O. Okay, this is said to be a character array. So if you want, I'll just take the indexes for the same. Let's have the indexes. Okay. So let's take the value 0, 1, 2, 4. Right? So if I would say the address is starting from 100, let's say. So this would be 101. This would be 102. This is 103. and the next one would be 104. So this is how it works, guys. Maybe I'll just take in double digit address. So 10, this would be 11, 12, 13, and 14. So in this way, you can segregate the addresses. Okay. Here, what is the value of CHAR? What is the value of CHAR, guys? Yes, CHAR is, I mean, it's 10, right? So CHAR plus 1, what do you get? I mean, of course, it's a data type, char. Maybe instead naming it to CHAR, let's give some different name, guys. Maybe STR. Okay. Or CH array. That's fine. Character is fine, na? CHARR. Character array. This would be fine. Okay. So CHARR is the value of 10. CHARR plus 1. What would you get? The answer would be 11. Okay. So this is the way, guys. So maybe if you work on strings, if you remember, let's say if you want to scan the value of a string, there is no concept of strings in C, but there is a concept of character array in C. So if you want to make this to a string, what you are supposed to do, just you need to have a special character called null character at the end. So let me just take on what is null character. So let's have the index 5. So this would be the null character. Yeah, I would explain slicing at the last. Yes, sure. Backslash node. Okay. Okay, this is called a null character. The address of this would be 15. So this is said to be a string, guys. So in C, if you remember, if you want to scan a string, how do you scan a string? By using scanf percentage yes, then followed by you can use ampersand str, or you can also write in this way percentage yes str even. Both of these works, guys. Why both of these works? Here CHARR is same. Similarly, address of CHAR also is same, right? The same case we have discussed over here. ARR meaning address of ARR meaning both are same. Here also CHARR or address of CHARR, it would be still the same. Got it, guys? No, pointers are not used in Python. Okay. Yeah, pointers are not used in Python. Okay, you can enjoy Python without pointers. Right. Good. Yeah, mostly you get the pseudocodes, guys. Pseudocodes meaning like irrespective of language, it would work. Okay. So you'll be able to understand what exactly is going on. Okay. So that's a quick intro to the concept of arrays, strings, as well as the concept of pointers. Now let's try to go with solving some pseudocodes. Okay. So before moving forward, I would like to hear so far any doubts or any questions to anyone. Yes, no in the chat. Good. All right. Fine, fine, guys. Yeah. So I would share this entire PPT with you guys. Okay. So this PPT is almost having, let's say, 338 slides. Among 338 slides, you should be able to see somewhere 150 different questions. So all these 150 different questions were asked in the previous Infosys exams only. Okay. So you can just walk through this. You'll be getting the idea. Okay. So even though you search for somewhere online website, so where you would like to find these pseudocodes, maybe from Prep Insta or any other platforms, you will be able to still see the same pseudocodes only. Okay. Yeah, you have the answers even, right? So I'll just start this slideshow. Okay, I see one query. I understand pseudocodes, but just can't understand these lead code questions. My logic is being stuck here itself. I keep watching tutorials and pseudocodes, solve basics arrays and strings, but lead code, nope, almost giving up coding. Okay, I'll try to answer all these questions at the last, guys. Okay, so at this moment, these questions might deviate from the topic. So I would take all of your questions. I'm pretty much happy to answer each and every one of your question. So just maybe the last 10 minutes we can go for Q&A. So I'll be answering all of your questions. Okay, no need to worry. Cool. Shalom. So let's say maybe, okay, you see here, guys, for each and everything. So like you have the question, options, and the answer. So what is the one? Okay, it's for everything. Okay, everything we have. Okay, I'll just take some example of a pseudocode. Maybe this seems to be a recursion, I guess. Yeah, we can go for this. Yeah, if you have paper and pen in handy, just try to understand what exactly happened over here. So here you are using, okay, maybe before coming to this recursion, I would take something, a small one more example of recursion, which would hardly take 5 more minutes, guys. Okay, just try to understand this recursion. Okay, so maybe I'll just take the yesterday's one. So like where we went for what the return type would be void, right? Function name to be fun, accept something like integer. Cool. Okay, so like I'll take if the value n greater than 0. Okay, you would go and call the same function by dividing by 2. This is what we have seen yesterday, right? Okay, this is what we have seen yesterday. And after this, we are trying to print the value of number. This is what we have seen yesterday. To the same thing, I'll try to add a small one more extra function. So can you tell now what is the answer for this? Okay, I'll just take the same one, guys, like fun of 4 only. 4 is the value which is being passed. Just understand carefully, take it step by step, and let me know what is the answer. Four is the value which is being passed. Just check it exactly what happens. No, so far no correct answers I see in the chat. No, not 0, not 1, not 2. Just take your time, guys. Just try to understand. So of course, in the yesterday, what did you get? You get the answer only one. No, right? What is the answer you got yesterday in our discussion? So what did you get? 0, 1, 2, 4. Correct. Now try to think the same way. How exactly it works over here. So for your reference, I also just take this 00, 11, 22, 44. No, that's even not. For your reference, okay. For your reference, this one. The question is on the left. The question is on the left. Okay. No, 0, 1, 2, 4, 0, 1, 2, 4. No, no. 0, 2, no. No, 0, 2, 4. Wrong. Hardly it takes like 30 seconds to figure it out, guys. So we should be very quick. 30 more seconds. Double 0, 1, 2, 00, 1, 2, 4. No, no, guys. No, no. 00, 11, 22, 44. No. Nope. Okay. So let me walk through. Okay, I see something. Yeah, I got the answer one from. I got the answer, guys. Yes. So Ranjita, yes, your answer is correct. Absolutely. Yeah, I appreciate. Good. So let's quickly try to see for the same how the recursion flow works on. Okay. So let's take quick over here, zooming out a bit. It's too high. Okay, guys, just first try to understand what is happening. What did we call fun of 4? Correct? Right. 4 greater than 0 is satisfied. Then what would you call? You would call fun of 2. After this fun of 2 is done only, you go to the next fun of 2. Am I right? After this fun of 2 only, you would go to the next fun of 2. After this entire if part is done, then you would go for the value 4. Is this right? This is what exactly happens. Yes. So now here, what you will be doing first? We'll be doing first this fun of 2. So this fun of 2 would be called. Let's go and call this. So now this fun of 2 would be called. So let's go call this fun of 2. So fun of 2 is called here. Right. So let's check. Is the value 2 greater than 0? Yes. So now fun of 2 meaning what do you get? 2 by 2, 1. Right. So again after this, what exactly happens? 1. Right. Okay, after these two are done, you would print the value 2. Correct? Okay. Still it is not done. Let's go complete and let's come back. So again from this place, what do? You go and call the value of fun of 1. So let's go and call it. Okay. Right. So fun of, let me change it. Good. So fun of 1, right? 1 greater than 0. Cool. Yes. After this, what would you do? 1 by 2, 0. Right? Next, fun of 0. Next, print the value of what? 1. Okay, after this is also done, next exactly what happens? You go and call which one? So we go and call the one which is fun of 0. So let's go and call fun of 0. So I'll just take it from this place to fun of 0. Now just observe, guys. Going over here, the last step, let's finish it off. Fun of 0. Is the value 0 greater than 0? Is it true or false, guys? Is it true or false? It's false. Condition got failed, you come outside, and what would you print here? What would we print here? We would print the value 0. Okay, so far we got to know that the output is 0. Okay, let's take it. Cool. Let's add 0 to our output. Done. Makes sense? Fine. So now what exactly has happened? This fun of 0 is done. Am I right? That fun of 0 is done. Okay, if that fun of 0 is done, then you have something which is left over the other fun of 0. Is this right? If again you go and call one more fun of 0, it would be same similar to this one. Is it right? Yes, correct. So again, what would you do? You again replicate the same output. What is the output? 0 is again now replicated. So far understood to everyone? Make sense? Yes. Okay, so far clear? Right. Okay, good. Now 0, 0 is done. After this 0, 0 is done, next what would you get? After this 2 are done, what is the next value? This 1. So let's go and print this value 1. Done. Now what exactly has happened? This first fun of 1 is done. After this first one of 1 is done, then what do you have? You have one more fun of 1. If you say one more fun of 1, meaning again this entire would be printed. Again this entire would be printed. So meaning again what exactly happens? The answer would be 001. the answer would be 001. Okay, so far until this step, let me explain once again. Okay, so let me explain once again until this step. Right. So going back. So first, what happened? This is a question. 4 greater than 0, 2 fun of 2's. Next 4, 2 greater than 0, 2 fun of 1's. 1 greater than 0, 2 fun of 0's. So fun of 0 you are trying to execute. 0 greater than 0 is failed. You have added the output to 0. Next, you have one more fun of 0. For that fun of 0, what exactly happens? So one more 0 would be added. So again here also what are you getting? 0. So 0 is printed. After these both are done, what do you have left over here? 1. So that 1 is added to our output here. So after this is done, again you see here one more fun of 1. For this entire this step would be repeated, meaning the output is still the same, 0 0 1. Is that clear until this step, guys? Yes. Right. Cool. So now exactly what happened? Now after this, you print the value 2. Correct? You print the value 2. Okay, now what happened, guys? Now what happened? Only if one fun of 2 is done. Only one fun of 2 is done. So we have one more fun of 2. Okay, so then now exactly what happens? Now this entire thing would be repeated. So meaning that this entire fun of 2 once again that would be called. So if this would be called again, what exactly happens? The same output would be repeated. So 001, 0012, you get it again. So after these two fun of 2's are done, then you get the answer to be 4. Yes. So this is the output. 001, 0012, 001, 00124. So this is what recursion, guys. This is how it works. Okay, yes, right, Lakshmi, you are correct. So this is what we get. So this is how recursion works in detail, guys. So this is the level of knowledge we are supposed to understand when you start preparing. So if you start something, start from zero, go until deep dive into the concept and learn whatever you want to grab. Okay. Then if you go further, any bit and corner, you'll be able to understand it very easily. So that's the power of problem solving. Okay. So programming is simply magic, guys. So once you understand the trick, see everything, the show would be pretty simple. Okay, so like if you fail to understand what exactly is going on, so even though you try to do lot many things, you still find it very difficult while going forward. Okay, so that's it, something about all the topics. Now let's get into the pseudocode part. Okay, now take this example, try to work. What do you get? Let's see. So what do you get for this? So first there is a value called A to 8. Okay, B value to 9. So both were passed. If A is less than B, some function is being called. If it is B not equal 0, so one more function is called with some return. Just try to understand what's going on over here. Guess the answer. Any guesses? So far, any? Okay. You want the options? Maybe? Okay, I'll just then try to copy this snippet. Yeah, I'm displaying the options. Just a moment. Just a second as it got struck. Yep. So this is a question, right? Okay, here go the options. Okay, I see some answers. Some with 72, some with 88. Okay, some with even. Okay, most of you, I see the answer to be C. Okay, okay, some with 88. And most of you, I see the answer to be 72, guys. Okay, let's try to see is it 72 or 88. Okay, what exactly is happening? Okay, first let's see over here. A value is 8, B value is 9. So there is some function which is being called, let's say, with the value 8, 9. Cool. A is less than B? Yes. Then what you are supposed to return? You need to return fun of B comma A. So 9 comma 8 is returned. Okay, again you go and call 9, 8. Okay, you go and call it and check the same. Is 9 less than 8? No. Is 8 equal to 0? No. Then what would you return? You return the value 0. First, just observe once again. Fun of 8 comma 9 is called. You are checking here. A less than B. Is the value 8 less than 9? Yes, condition got satisfied. Then what exactly is happening? You return the value function of B comma A. So what is the value B? B is 9, A is 8. So B comma A is being returned. Cool. So we went to that return fun of 9 comma 8. Again you went there. Again check. Is the value, this is now A, guys. This is the value now A. So this is the value now A. Okay. So what's A? It's 9, correct? Right? So what is B? It's 8. Okay, fine. So now what you're trying to check, is the value 9 less than 8? Is this condition satisfied? No. So again you go to check what? Yes, condition is failed. Is the value 8 not equal to 0? Yes. Else if 8 not 0 satisfied, what you are supposed to return? So you need to return A plus. What is A? 9 plus function of what would be called A comma B minus 1. What's A? A is 9. What's B? B value is now 8 minus 1, which is 7. So now function of 9 comma 7 would be called. So again, what happens? You would return. Yeah, A is 9, right? Yeah, 9 plus we are doing in the right way only. How A is 9 is your question. Okay, here already we got to know A is 8, B is 9, correct? So function of 8, 9 is called, right? Is the value 8 less than 9? Satisfied. What you are trying to do here? Function of B comma A, right? So B comma A meaning this is B. So B came to here. This is A. So A came to here. So now this is A comma B again. So again, when you work on this function, this is A comma B. Right, here 9 is not less than 8. This condition got failed. Again you go to else if 8 is the value 8 not equal to 0. Yes, condition got satisfied. As the condition got satisfied, what would you return? You would return 9, which is A. 9 plus function of 9 comma 7. So again 9 is not less than 7. What would you return? You would return 9 plus. Okay, let's see what's the answer. Let's see. So again, what happens? 9 plus 1 of 9 comma 6 happens, right? Until how many times this goes on, guys? So again 9 plus fun of 9 comma 5. Similarly 4, 3, 2, 1. So let's say maybe I'm just quickly writing here 4, 3, 2, 1, and next comes 9 comma 0. Here, what is the value of your B? 0. So once it is 0, what you are trying to return? 0. So B not equal to 0 means 0 not equal to 0 failed. You return what? 0. Here, what would you return? You would return the value 0. So 0 came to this place, but in all these previous places, so starting from this, you have 9. 9 plus, again 9 plus, again until where? Until this respective point. So 1, 2, 3, 4, 5, 6, 7. Right? So all these places you basically have the value 9. Got it? So how many nines you see, guys? 1, 2, 3, 4, 5, 6, 7. So one more case where it is missed. Hold on. Yeah, 8 times basically. So one value is missed over here. So 9 plus, let me just take this to down a bit more. It is to 3, guys. This is to 3 and this is to 2. This is to 1. Let's also add it for. So how many nines you see, guys? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 nines, the answer would be 72 plus 0. So the answer would be 72, which is the option C, guys. So option C would be correct. Okay, let's check the option. The option C is right. Okay, can you just go through this? What would be the output for this following pseudocode? Yes, we need to add all 9. Why we need to all add 9? Because you see return, guys. Return. At every point you see return. So what exactly has happened? When you return this 0, sorry. So when you return 0, what happened? This 0 is the value where came to over here. So again, now what are you trying to do? 9 plus 0 means what is 9 plus 0? 9 plus 0 meaning the answer would be still 9. So this is returned to this place. What is 9 plus 9? 18. So 18 would be returned to this point. Okay, to this place. Now again 3 nines is returned to this place. Correct? So all these places you return, return, return. If you won't return, it would be at the last point only. Yes, we need to add all nines because that is the value which is being returned. Cool. That's the reason you got the answer to be 72. Okay, just go through this, guys. Meanwhile, just snip it. Yes. Pretty easy one. I'll also get the options for the same. Yes. F to 6, G to 9, sum to 0. So what do we get? G greater than F. Yes, if condition got satisfied. N starts from F. N goes till where? Okay, I see one answer. Okay, 2 answers I see. Couple more. Most of you with 21. So of course you guys might not be wrong. Then the answer might be definitely 21 only, guys. Okay, so let's quickly see it out. So n value starts from where? So G greater than F, yes, 9 greater than 6, satisfied. N starts from where? F. So N is starting from F. What's the value of F? 6. It goes until where? N less than G. So what's the value of G? 9. So meaning 6, 7, 8. 3 iterations it goes on. Okay, 3 iterations it goes on. Each and every time you are incrementing the value of n by 1. Okay, sum equal to sum plus n. So 6 plus 7 plus 8. So 6 plus 7 plus 8. So what's the answer you get? 6 plus 7 is the value 13. 13 plus 8, the answer is 21. So of course the answer would be option A. So option A is the right. Correct. So option A is the right. Okay. So let's go for next. Yes, option A, guys. Correct. Just check this one. So you just observe here this question. How n equal to 6? How n equal to 6? Meaning, you see, guys, here n value is assigned to f, na? So what is f? F value is 6, right? They have given to us. That's the reason. Okay. So n equal to 6 to 9 meaning what happens? 6, 7, 8. 3 iterations would be satisfied. That's the reason 6 plus 7 plus 8, you get the answer to be 21. So let's go for this. So here, what should be the value of the variables num1 and num2 in the code below if the output expected is 4? Just observe this thing. So what should be the value of num1 and num2 if the below code output expected is 4? Try to understand here, guys. Yeah, after you increment the value of n would be 7 only. Yes, yes, here after you increment the value is 7, na? After that you increment the value is 8. After that you increment the value is 9. So like meaning what, guys? First 0 plus 6. To this what you're trying to do? Plus 7. To this what you're trying to do? Plus 8. Correct? 6 plus 7 plus 8. That's the result, right? Okay, what's the answer for this, guys? So I see 8 comma 2. Someone with 12 comma 5. 16 comma 2. Okay, let's quickly check it out, right? So one by one, okay? So maybe I'll just take the same thing, copy. So we don't know what are the values of num1, num2. So of course, in this way, we are supposed to debug, guys. Okay, let's take it. Okay, so given options are what to us? 12, 5, 8, 2. Let's take one option one by one. First, let's start from the first 12 comma 5. Okay, 12, 5. So num1 is 12, num2 is 5. Is the value 12 greater than or equal to 2? Yes. Is 12 greater than the value 5? Yes. Satisfied. So 12 equal to 12 by 2. So what do you get the value of num1? Let me just take num1 to 12, num2 to 5. Just check it, guys. Just check it what exactly is happening. 12 greater than or equal to 2. Yes. 12 greater than 5. Yes. So 12 equal to 12 by 2. So what is 12 by 2? Now you got 6. Okay. While loop, you again go to the top. So num1, what is your num1? 6. 6 greater than or equal to 2? Yes. Is 6 greater than 5? Yes. Okay. 6 by 2. What do you get? 6 by 2 meaning the answer is 3. Right. So we got the answer to be 3. Again, you go top. 3 greater than or equal to 2? Yes. Is 3 greater than 5? No. Condition failed. So else, and you print what? Num1. So in the first case, you are getting the answer to be 3, guys. So of the first option is wrong. So this first option is wrong. Let's go for second option, 8 greater than 2. So 8 greater than or equal to 2? Yes. 8 greater than 2. Fine. 8 by 2, 4. So again, you go to top. 4 greater than or equal to 2? Yes. Is 4 greater than the value 2? Yes. So 4 equal to 4 by 2. This condition got failed again, like 4 by 2 means 2. So again, you go 2 greater than or equal to 2, 2 by 2, 1. So answer is still not 8 by 2. Is the answer 8 by 2, 8 comma 2? No, this is also not the case, right? So num1 is the given value 8. num2 is the value what? 2. So first 8 greater than equal to 2 means 8 by 2 what happened, guys? 4. 4 greater than equal to 2. 4 greater than 2 what happened? 4 by 2, 2. Again 2 greater than equal to 2, 2 by 2. Condition fail, you are printing the value 2, guys. This is also the wrong option. Okay. Next, of course, you go with the value. See, let's try to understand 16.6. So taking the example of 16.6. So num1 would be 16. num2 would be 6. 16 greater than or equal to 2? Yes. 16 greater than 6? Yes. 16 by 2, what would you get? 8. 8 greater than or equal to 2, while loop satisfied. 8 greater than 6 satisfied. 8 by 2, what do you get? 4. 4 greater than or equal to 2. 4 greater than 6 got failed and you're printing the output to be 4, guys. So the correct answer would be 16 comma 6. Yes, the answer would be 16 comma 6. Let's try to see the option. Yes, option C is right. Option C is right. Correct. Okay. So this is one more example of recursion. Add 1, add 2. Can you try this out, guys? So here there is a function called add. There is a function called add. This is add function. This is a function of add 1. Just check this. First, what is happening over here? So this function will not be called. This function also will not be called. So print statement is called. So in print statement, what you are trying to do? You are trying to call the function as add. So for add, what is the value you are being passed? 5. So you got the value 5. 5 not equal to 0. Cool. Then what would you return? Which one you want me to explain again? The previous one or this one? Previous one. Okay, this one. So like what happened here, guys, is option C. Let's take it slow. num1 to 16, num2 to what? 6. Try to understand the first step. Okay. Is 16 greater than or equal to 2? Yes. Satisfied. Is 16 greater than 6? Satisfied. So 16 equal to 16 by 2. What is 16 by 2? 8. Okay. So else block will not be evaluated. Go top. num1 greater than or equal to 2. Is the value 8 greater than or equal to 2? Yes. Is the value 8 greater than 6? Yes. Satisfied. So what is 8 equal to 8 by 2? 4. So again you went top. 4 greater than or equal to 2? Yes. 4 greater than 6? No. Now you go to else and what would you print? You would print the value 4. Understood? So the question is we need to get the output 4. In order to get the output 4, what is the correct option they were asking to us? Understood? Cool. All right, let's go to this one. So what we are trying to discuss. So let's say add 1 and add. So for add, what is the value which is being passed, guys? 5. So 5 not equal to 0, satisfied. Now what would you do? You would pass add 1 with the value what? 5. So 5 is passed. Went over here. 5 not equal to 0, satisfied. Now what you're trying to do? 5 plus 2. 5 plus 2 is 7. 7 plus again the same function add 1 is being called. So n2 minus 1. n2 minus 1 means n2 is a value 5. So 5 minus 1. So means add 1 is being called again with the value 4. 4 not equal to 0. Yes. So 7 plus again this 4 plus 2. 6 plus again add 1 of 4 minus 1 which is 3. So again 3 pass, 3 not 0, return what? 3 plus 2 which would be 5 plus add 1 of 3 minus 1, which is 2. 2 is passed, 2 not 0. 2 plus 2, what would you get, guys? 4. Again, plus. Okay, let me explain. Hold on. Yeah, fine. So let me just see, guys. First, what's happening? Let me change the color. Add function is being called in our print. What is the value which is being passed? 5. 5 came over here. 5 not equal to 0, satisfied. So what is now exactly happening? Add one of 5 is being called. Cool. So now you go and do what? You go and call. So maybe I'll just take it directly in the paint, guys. Okay. No worry. I'll take it in the paint. We'll see it there. Okay. So you might get hardly one question on recursion. Okay. So whenever you see the questions on recursion, so patience is very important, guys. If you break it at any point, it will be very hard to understand. Okay. Consider this. Going over here to paint. Chalo, let's see, guys. So we have 0 at last, and there is one more thing which is print add of 5. So this is the statement what we are working on. Okay. This is the statement what we are working on. Okay. So now here, first, what function is being called? Add of 5. So add of 5 meaning what? The value 5 is being passed here. 5 not equal to 0, yes. So add 1 of 5 is being passed. Okay, you went over here. So you got the value 5. 5 not 0. So next, 5 plus 2, what do you get? 7. Okay, 7 plus what, guys? Add 1 of 5 minus 1. N2 is the value 5, right? 5 minus 1 means 4. So again, what happens? Add 1 of 4. So 4 is being passed now. 4 is not 0. Return 4 plus 2. What is 4 plus 2? 6. 6 plus add 1 of. So what is the current value now here? 4. 4 minus 1 meaning what? You get the value to be 3. So again, 7 plus 6 already there. Now 3 is not 0. 3 plus 2, what do you get, guys? 5. So 5 plus add 1 of what, guys? Add 1 of 3 minus 1, which would be 2. So next, again, 2 not 0. 2 plus 2 what? 4. 4 plus add 1 of what here? So 2 minus 1 is 1. So next, 1 would be passed. 1 not equal to 0. Yes. What is 1 plus 2? 3. 3 plus and 1 of 0. So now 0 not equal to 0. Condition failed. As the condition failed, you go to else block, and what would you return? You return the value 3. So now 3 is being passed to where, guys? Exactly to this place. So now 3 plus 3, 6 is being passed to where? Exactly to this place. 4 plus 6, where it is being passed to this place, which is 10. So 10 plus 5, what happened? 15 to over here. 6 plus 15, what happened? 21 over here. 21 plus 7, what exactly you got? 28. So 28 is a value which is being traced and returned from this function. So now here we got the value as 28. Cool. So this is so far clear, right? So now next what happens? Plus add of n1 minus 1. What's n1 here? 5. So 5 minus 1 is 4. So now you went over here. Again, you see here 4 not equal to 0. So when 4 not equal to 0, what exactly has happened here? Again, you go and called add 1 of n1. So what is add 1 of n1? Now the value 4 is being passed. So again, you came over here. Again, you would check, guys. So when n2 is 4, what did you get? When n2 is 4, what did you get? This value, right? 6 plus 15. 4 plus 2 is 6, right? 4 plus 2 is 6. You got this value. So 6 plus 15 is what you get when you were add one. Yes. Is this right? Is this right at this moment? I'll just explain this line once again. Just be very careful. So 28 plus add of 4. So now what is the value which is being passed? So now 4 is the value which is being passed. Now again what happens, guys? Add 1 of 4. So meaning for this one, what you are doing? Add 1 of 4 plus add of 4 minus 1, 3. So after this, what happens? For again this add 1 of 3 plus add of 2, right? Next over here, what happens? Add 1 of 2 plus add of 2 minus 1, 1. Next, what exactly has happened? Add of 1 plus add of what? 1 minus 1, 0. So 1 minus 1, 0 means what you are supposed to do? This condition is failed, means what would you return? 0. So this is returning the value 0. Correct? So what would this add 1 of 1 return to us? If you evaluate earlier, here when the value 1 is being passed, 1 plus 2, 3, 3 plus 3 got evaluated. So meaning this is the answer what we got. This is the answer what we got. Where? So to this place. So now 3 plus 3 plus 0. What's 3 plus 3 plus 0, guys? 6. So now 6 is the value at this entire place. So 6 is the value at this entire place. Then what is add 1 of 2? So when you pass the value 2 here, 2 plus 2, what happened? 4. So 4 plus something, which is 6. So again, this we got. It's 10. So 10 is the value at this place. Correct? 10 is the value at this place. So now this entire result would be this one, guys. 4 plus 6 plus 3 plus 3. Then what is add 1 of 3? Add 1 of 3 is nothing but 3 plus 2, 5. So 5 plus 10 is the value what we have looked in exactly. Right? This entire thing we got it over here. Now just take the same thing to the top. Right? So what is add 1 of 4? 4 plus 2, 6 plus 15. This is the thing what we have considered over here. Correct? So this thing we considered. So now what exactly would be sum of all this? Let's try to add up, guys. Okay. So 6 plus 15 plus 5, 20 plus 10 plus 10 again plus 6. So 20, 30, 40. So 40 plus 6, 46. So this would be 52. Yes, 52 plus 28. So what would you get? 30, 40, 50, 60, 70, 80. Yes. So what is the answer? Now we got 80. So now let's go and see for the option 80, guys. If you fail to see the option 80, then we are not good at recursion, guys. So how many of you are confident that the answer is 80? Yes. So I see everyone saying answer is 80. So let's go and see for the option to be 80. Yes, guys, we got the answer to be 80. Understood? This is how it works. Make sense? Right. So few more pseudocodes are left over actually. So as of course we have already almost hit the time 9. So we'll try to see that in the remaining session, guys. Okay. So I would like try to stop at this point. So I would like to hear any queries from your end. Yeah, just a bit more practice actually we need. Okay, slicing I missed it actually. We might cover that in the next class. Okay. Yeah, I will share the PPT. No need to worry. Yeah, I'll send the PPT. Just give me a moment, guys. No, we don't have the coding for Infosys pattern, guys. Okay, only pseudocodes. That too, you get 5 pseudocodes for technical. Okay. So drive plays and drive dates, I'm not sure. Maybe you need to check with your college TPOs and your coordinators. Okay. Okay, just a moment. So questions level would be easy to medium, guys. One question might be of hard. Yeah, interview process might be of 3 rounds. So first you go with the technical round. If that is done, you might go to HR. If in between, there might also be one more technical round. Okay, two technical rounds followed by one HR round. Or probably one technical round, one HR round. Okay, one great thing how you're supposed to solve it in less time is just you need to be very quick when you understand the basics, guys. So if you're taking the tracing part for the second time, of course you have wasted the time. Okay, you're not supposed to do that. Okay, so like when you start, just start with very fundamental thing. Okay, so the fundamental starts, just be very perfect in all the concepts. Okay, you can go through the YouTube playlist what I have shared. Just be thorough with all the concepts, how those are working. Okay, so all those would be fine. Okay, there are no questions on operating systems, computer networks, and DBMS, guys. On pseudocodes, there are no questions. They might be asking the technical rounds based on your resumes. Okay, if your resume is, let's say, you might be having DBMS operating systems. So cutoff would be like overall, guys. Like we can't like to each and every round cutoff. Okay, you want me to send the playlist again? Okay, I can send it once again. Just a moment. Yeah, I have again sent it in the chat, guys. Okay, how much is the intake? Seriously, I'm not aware, guys. Okay, so PPT also I would share. Okay, I would share the PPT. Just hold on.
Just want to bring up that the recorded session and slides and PPT that the trainer would like to share will be available on the same place where you got the link on the platform.
Yes, yes, guys. All right. Any other queries, guys?
So
Okay,
thank
all
you,
the
everybody.
rounds. Yeah, thank you.
Thank you, Kushal sir.
Thank you, sir.
Just a quick reminder, we sincerely request all of you to fill in your profiles in the Xcelerator, CPC's Xcelerator platform. This will help you open up more opportunities for you. And you can reach us if you have any issues with that. Feel free to reach out to the team. And there's a session tomorrow evening again, so look forward to you there. Thank you. Thank you, everybody. Good night.
Thank you, everybody.